Hi, I'm Dr. Michael Greaves, the Chief Scientist for Advanced Manufacturing at the Florida Institute of Technology. And I'm here today to talk to you about digital twin maturity and how we need to sort of transition from concepts to value creation. And I want to set the stage by talking about the fact of how are we going to create value. And the idea that we create value here is that the core underlying premise is that information is a substitute for task wasted time, energy, and material. And what I'm saying about that is the fact that for any task, which is I define as a goal-seeking activity, we can divide that task into two categories. And as you can see from the bar there, the lower green category is the most efficient use of resources that we can deploy in order to accomplish that task. Um, all the other resources that we deploy doing that are wasted resources by comparison to the lower green area. And by a task, I'm talking about pretty much any kind of thing that you can think of in terms of how human life operates. And so within the product area, it is designing a product that is going to have the functionality that the user is going to want to acquire. It's manufacturing the product with the minimal amount of resources. And in point of fact, we've been focused on that for a while, and it even has a name. It's called lean manufacturing. And the intent there is to get rid of any wasted time, energy, and material that we don't need in order to produce that product. When we're supporting the product, the ability of keeping that product operational and repairing it in the least amount of time when it's taken offline is the task that we're looking at. And in point of fact, in human existence, we have the task of figuring out how to get 3 kids to their various practices after school in terms of playing sports or other activities. So this is sort of the premise in terms of we have these tasks. They have the most efficient way of doing those tasks, and an inefficient way is above that. We can cost those tasks. We live in a capitalistic society, so we can cost the time, energy, and material in order to be able to do that task. And for time, it's not only the time that we deploy, but it's the overhead time that the longer the time goes on, we have overhead time, especially in businesses that keep racking up from minute to minute. Where we're looking at this is the fact that information is a substitute, not for the amount of resources we need to physically complete the task, but for the information inefficiencies. So taking my examples from before, it is basically designing a product that has already been designed before and could not have the functionality that we require, or in point of fact, the product has already been designed before and actually exists and does everything that we want it to do. So designing a new product is a waste of resources. In manufacturing, it is running out of stock at a station and having to shut down the operation, waiting for more inventory to reach that point in time. For repair, which is a very common one, it's not knowing how to disassemble the product efficiently, and so we waste time doing trial and error, figuring out how to get the part out and replace it with a new part. And in point of fact, even my example of getting 3 kids to their practices, it's finding out that one of the practices has been canceled and another of the practices have been moved to a different field. And so we've wasted time basically even doing that. So information is this idea that we're going to replace wasted time, energy, and material. And obviously, since there's cost there, it creates value for us if we can do that. Now, information is not free. There is a cost of information, but it doesn't have a unit of measure like time, energy, and material. And so our focus there is we can get to a proxy by looking at all the costs that we have to create information, be able to store it and retrieve it, and the systems and software and hardware that's involved in doing that. The reason this works is that that the cost of wasting uh, resources needs to be greater than the cost of information. And I think that over the last 50 to 70 years, as computers have come online, we have shown that that is particularly the case, that we can actually do that. And so for one-time situations, we wouldn't create an information system. But if we're doing repeatable things, it's clear that if we create information, we can replace these information inefficiencies. And the opportunity here can be fairly large. And I want to show you an example that I developed with my sister-in-law's daughter, who is a Caltech graduate. And we looked at this example and said, okay, if this is a simple one, but it's going to give you an indication of kind of the value that we create. If I have a matrix that's 1,000 by 1,000, and periodically, in fact, on a regular basis, a nugget of gold is placed on that particular matrix. And we have a little machine over here in the lower left-hand corner that basically has to go out and find that piece of gold and bring it back. And the costs are, the cost to move this little machine one square costs me $1 every time I move it a square. I can move it anywhere I want, but it costs me $1 every time I make a move. If I'm simply have no information about where that nugget is the cost, the expected cost over all the times that I do that is going to be $500,000 plus the $1 to move back. So if I have no information, my expected cost is $500,001. If I have one piece of information, the X or the Y value, my costs go down to $501. But if I have two pieces of information, both the X and Y, I can simply move to that spot and my costs are $2. So you can see this is a huge, huge opportunity here in this simple example, but I will contend that those examples on a more complex basis exist every day as we've traded off information for wasted resources. So I go from $500,001 down to $2. Now, the cost of basically instrumenting this, which would probably be an IoT device that says, do I have a piece of gold in there or not, is not in here. But you know, the cost of that one time to instrument this certainly would make it worthwhile the more I'm doing this search for gold in my matrix. So this is just a simple example that I wanted to show you that is indicative of information as a replacement for wasting resources. I want to kind of move to what I call the digital twin value map, because the issue here is being able to look at how do I create value. And for an organization, in fact, I've used this in many board meetings, and it's being taught in some MBA courses, is that that creating value is based on the fact of a change in income over the assets I need to basically produce that income. There's only sort of two ways I can change income. One is by revenue, and the other is by cost. I can increase my revenues or I can decrease my costs. The cost is pretty obvious. At the end of this structuring, I have people with a time and rate, and I have material. And those are pretty much the two things I buy. I mean, an example of this is a Boeing 747 costs about a couple $100 million, but in terms of the material, it's about $2 to $4 million of actual material. The rest is value add of people at a time and a rate, and obviously a profitability, which is their income. On the revenue side, it basically is consistent of price and quantity. If I sell more at a higher price, I get more revenue. And price is basically on the ability of the more functionality and the better quality I can have, the higher the price that I can charge. And so this is what drives all organizations in a capitalistic society to, in essence, determine whether they're going to invest in those assets that are the denominator for income. We usually use justification of cost as the reason for it, but the promise of increased revenue is always there. But it's only through the internet, the internet age, where we had .coms, did I see people justifying large expenses on the basis of revenue. I want to kind of so that's sort of the underlying premise that's behind the digital twin value map. And in essence, if I can create this information, I can both reduce my costs and, as I'll talk about in a second, increase my revenue. The focus here in terms of the digital twin value map with revenue is, if I look at revenue, when I go to the digital twin, I now have sort of two categories that I can look at in terms of increasing my revenue. The first is the products that I showed in the previous slide. And so I can sell more products at higher cost, ideally, and it'll have better quality because I have better information about how the product performs. But I now have an ability to actually sell that information. And information, the economists call a non-rival good. If I sell products, it basically costs me to make that product, and the material that I buy to produce that product is gone once I sell that product. With information being a non-rival good, I can sell that information over and over again, and I don't diminish the amount of information stock that I have. And so there's a real good reason to create digital twins and create this information stock, because I continually can sell that information to my customers in addition to selling the products. Now, I'm also assuming that I'm incorporating that information into the products to get better either pricing or sell more of them, but I can actually do it in both categories: sell it through the product itself, or basically be able to sell the information in terms of, how is your product performing, predicting failures. And the more population I have of products across a wide customer base, I can do a better job than the customer can do itself in terms of being able to correlate sensor readings, for example, with the succeeding faults, and be able to start to predict that kind of failures. I'm fond of saying that, as a frequent flyer, I don't want an engine failure over at 3,000 feet, 30,000 feet. And in fact, I don't even want the failure to occur when I'm sitting waiting for the flight to board, because that means probably a long delay and a waste of my time. I really would like to do is predict that the engine component is going to fail, and the next time through the hub, have that replaced. So these sort of two value maps are where we're going to get value from digital twins as we move forward in time. Now, it's going to be critical that we have our digital twins reflect reality, and that when we model and simulate those things, that the actual physical product is going to do the same. And so we're going to have to spend resources in development in terms of that capability. So that asset number that I'm showing below may be a pretty significant number, but over the amount of products that I'm selling, it can be fairly substantial increase in value as my income increases fairly dramatically with the cost of my investment in information. So the digital twin value creation has kind of these two uses. In the internal use, it's cost reduction in terms of productivity and time to market. And again, as I mentioned, we have two measurements of time. One is the amount of labor time that we deploy in these things, but clock time has a substantial cost in terms of every tick of the clock means that overhead is increasing. And in point of fact, time to market is, if I miss my being first to time to market or early, I could basically spend all my time developing a product, and my competitors are going to, in essence, beat me out of that, and my investment has been wasted. For an external use, is basically this revenue increase. I can sell it to customers. I can sell it indirectly in terms of adding it into my product itself as part of the product offering. I can sell it directly by selling them information about how the product is running and performs, and also comparing that to the products that other customers have to see if my product as a customer is basically performing the same way that everyone else's is. So this is where the digital twin value creation is going to come about. And we need to focus on that kind of how do we develop that with the resources that we have, and how do we have a digital twin do that. Now, I will just briefly at the end kind of show you use cases that are going to drive this. So I just want to spend a little time talking about sort of what is the product life cycle, classic product profitability curve. And this is the curve of the product profitability over time. And as you can see, initially I lose money. I mean, I'm basically developing the product, it's costing me money, I'm not selling any of it. When I get the product launch, I then start to sell my product, and over time, I reach the peak and the product sales taper off. Now, this is a Gaussian curve. A lot of it's an ideal. There are all kinds of different models of this. I mean, you can have a huge increase in product at the beginning and then dropping off fairly quickly. But the idea that says that I have a time where my product is increasing in popularity and I'm making more profit, and then decreasing. At product sunset, my revenue goes away. I'm not selling any more of this product. However, my cost, my warranty cost, my liability costs continue on. And so my focus there is the fact that I have money that I'm losing after I stop selling a product, even though I may have made a lot of money during that period of time. The digital twin profitability curve looks like this. And again, it's an ideal in my perspective of it. But if we do this right with the digital twin, in the development side, we should be able to develop products faster at less cost, although we may have to invest a little more at the beginning in order to have the digital capabilities that we want. So the whole idea is with digital twins, I can launch products faster, which means less cost. I can sell more of those products. Now I have an additional revenue in terms of the information. But at sunset, the difference is I can still sell information after product sunset. And I'll give you the example is Apple phones, they stopped selling a particular version of Apple phones, but people still keep buying songs and apps after that. That's sort of an additional product add-on, but I can also extend that to product services in order to keep products operational for a longer period of time. So the digital twin use cases that we're looking at here are in all aspects of the product's life cycle. And so in terms of the create phase, we can basically get value out of all these different use cases. So requirements development and verification, the ability of being able to then model and simulate a product to determine whether or not it actually is going to produce the results that the engineers think it's going to have. Pre-release collaboration, the ability of having people, no matter where they are in the world, collaborate on the design is an absolute critical piece, and will reduce it. The idea with a digital twin is I can have simultaneity and instantaneous sharing of information, where with classic product design, if I, for example, have to build a prototype, I have to in essence, be able to either ship that all over the world to have people look at it, or bring people into my location. Both of those are fairly costly. And so being able to look at, using the digital twin, and I might point out, the digital twin absolutely can have huge value during the creation phase, even though there isn't a physical product, because what we really want to do is to design the product virtually, test the product virtually, manufacture the product virtually, and support the product virtually, and make all our mistakes virtually before we ever start to move around expensive atoms. In the build phase, rapid prototype, digital mock-up units, so the ability of not having to build prototypes, but using digital capabilities. Modeling, the factory simulation are critical aspects of being able to build our virtual factory and work out all the lean manufacturing aspects virtually, as opposed to doing that in a physical basis, which costs money. So even though the Toyota production system has been sort of the model of, how do I look at waste and remove that from the factory, the far better way is to do this virtually. And then obviously and this is an area that has not gotten a lot of attention, is the usage and sustain area, the ability of being able to keep the product running and predict product failures before they occur, so that they are repaired before the problem occurs and causes downtime, is a huge opportunity. So prognostics, being able to augment the product, being able to sell the user information about their product so that they can keep their product up and running, or even improve the capabilities of that product for the user, are sort of critical aspects that are key here. And so these are only some of the use cases. I do not contend that this is a comprehensive list, and I'm in the process of updating this list all the time. But the whole digital twin uses are in all categories, all phases of the life cycle. And again, as I mentioned, the digital twin before there actually is a physical product is fairly critical in being able to create value. And so with that, I'd like to kind of just share resources if you're have an interest in diving deeper. I have 2 book chapters that sort of are the seminal works in this particular area, and define what the digital twin is, the different types of digital twins, which is critical for having the right type of digital twins for the right aspect of the product lifecycle. And so with that, I'd like to invite you to have a very knowledgeable time at the rest of the conference, and hopefully you'll go away with a lot better understanding of digital twins and the value opportunities that exist on a continual basis. Thank you.